Good morning everybody. Myself Dr.M.UMADEVI, Assistant Professor in Physics, Sri Parashakti College for Women, Kutralam. In this video, I am going to discuss you about the fundamentals in optics. Anything which is related to light comes under optics. Optics is a branch of physics that studies the behavior and properties of light, including its interaction with matter and the construction of instruments that use or detect it. Optics usually describe the behavior of visible ultraviolet and infrared light. Next, we'll see the branches of optical sciences. In optics, there are three types. One is geometrical optics, second one is physical optics, and third one is quantum optics. Geometrical optics is the study of light as rays. Physical optics deals with the study of light as waves, whereas the quantum optics deals with the study of light as particles. In this video, I am going to deal only with the geometrical optics. We know very well that optics is a branch of physics that concerning the interaction of light with matter, whereas geometrical optics or ray optics is a subset of optics concerning the interaction of light with macroscopic material. So macroscopic in the sense, the dimension larger than human hair, approximately 50 mm. In this video, we will have a discussion only on reflection and refraction. Since I know very well that students always have a confusion about this reflection and refraction, even though they are studying from 6th standard. I hope after looking this video, it will be very helpful and you can understand well about this reflection and refraction. Everybody knows that light is an electromagnetic wave. In this video, this E denotes electric field where B denotes magnetic field. Light rays will travel in a straight line if they remain in the same medium. And this light can travel through empty space, air, glass, water, cornea, that is the white part of the eye lenses, etc. This empty space, air, glass, etc. referred as a medium. Next, a reflection of light. When a ray of light approaches the smooth polished surface and the light ray bounces back is called the reflected ray. At the boundary between two media, the light ray can change the direction either by reflection or by refraction. Let us move to the reflection of light wave. So here I have considered a smooth surface as a mirror. This is an incident ray and this one is a reflected ray. We know that in a smooth surface, whatever may be the smooth surface, either it may be a mirror or a solid space, anything, all the ray will be getting reflected. This eye is an incident ray or is a reflected ray. As I told you earlier, for a mirror or any smooth metal surface, all the light ray will be getting reflected. Next, we'll see what will happen when the light hit the optical surface. When the light is incident on an interface between two transparent optical media, it may be between air and glass or between water and glass. Any one of the four things may happen. It can be partially or totally reflected at the interface. Second, it can be partially transmitted via refraction at the interface and entering into the second medium. Third, it can be scattered in random direction at any interface. Fourth, it can be partially absorbed in either medium. I hope you can understand clearly. So let me discuss you again. When the light hit the optical surface, any one of these things may happen. Either it may get reflected or refracted or scattered or absorbed. So next, laws of reflection. You know that according to the laws of reflection, the angle of incidence is equal to angle of reflection. That is, I is equal to R. What is angle of incidence and what is angle of reflection? The angle at which the light hits the reflecting surface is called the angle of incidence, and the light at which the light bounces off the reflected surface is called the angle of reflection. So here this is an incident ray and this one is a reflected ray. This A is angle of incidence and B is angle of reflection. This one is a normal. So this is denotes the plane of incident and it is falls on the reflecting surface, smooth surface. It may be a mirror or any solid surface. So here the incident ray, reflected ray are normal. All the three lie in the same plane. Next, types of reflection of light. There are three types of reflection. One is regular reflection or specular reflection. Second, diffused reflection, and third one, multiple reflection. So this picture shows the regular reflection, or you can name it as specular reflection. So you can see clearly this pink color denotes incident ray, this green color denotes reflected ray. So here the angle of incidence equal to angle of reflection. That means all have the unique angle. Whereas in the case of diffused reflection, the angle is not unique. I think you can understand clearly by looking these two diagrams. Then third one is a multiple reflection. The multiple reflection takes place within the two boundaries. Again, I'll discuss you about the specular reflection. The specular reflection takes place in a smooth surface, whereas the diffuse reflection takes place in a uneven surface. See here, the specular reflection, in specular reflection, there is a unique angle of reflection for all the rays. That means the light reflected in one particular direction. Whereas in diffuse reflection, there is no unique angle of reflection for all the rays. That means the light is reflected in all the direction. There is no uniformity. This picture shows the regular or specular reflection. This is the photo of lake which reflect the image in a clear way and in a regular way. And the majority of the object like clothes, plants, people, etc. are visible because they reflect light in a diffused manner. That means these all are the examples of diffused reflection. So next we will see what will happen in a concave mirror and convex mirror. This is the reflection of light in a concave mirror. In concave mirror, the light ray travels towards the mirror in a straight line and are reflected inwards to meet the point called the focal point. F is a focal point and C is the center of curvature. So this is the principal axis. So here each ray hit the mirror and it travels towards the mirror in a straight line and reflected inwards and meet at a particular point. So when the parallel light ray hit the concave mirror, they reflect inwards towards the focal point F. So here each ray will get reflected at the same angle and hit that small part of the surface. The example for concave mirror is inside the curve of a spoon is the best example of concave mirror. So where we are using this concave mirror means the concave mirrors are used in certain types of astronomical telescope called reflecting telescope. Concave mirrors are useful for makeup mirror because they can make things seem larger. This concave shape is useful for car headlights and satellite dishes. Next, the same things with convex mirror. So this is the convex mirror. The convex mirrors are very useful in security systems. When the parallel light ray hit the convex mirror, they reflect outwards and travel directly away from the imaginary focal point. I think you can understand clearly. In concave mirror, the light rays reflect towards, whereas in the convex mirror, the light ray get outwards, reflect outwards. Here also each and every individual ray is getting reflected at the same angle and focus at the particular point F. F is a focal point. So the example of this convex mirror is the curve outward like outside the balloon. Refraction. Refraction is the bending of light. It also happens with sound, water and other waves. When it passes from one medium into another medium or one substance into another substance. This bending by refraction makes it possible for us to have a lens, magnifying glasses, prism and rainbows. Even our eyes depends upon this bending of light. Without refraction, we could not able to focus light on our retina. Refraction. At the surface of transparent media, glass, water, etc., both reflection and refraction occur. That we know very well, that I discussed in the beginning. Refraction. Refraction is nothing but the reflection from a straight line when it is passing from one medium into another medium. See here, this is a normal and this is an incident ray, and here the part of the ray is getting reflected and part of the ray is getting refracted when it is traveled from one medium into another medium. The refraction of light in water. When the light rays travel from air into water, it shows down, causes it to change its direction slightly. This change of direction is called refraction. When the light enters a more dense substance, it bends more towards the normal line. See here, in this diagram you can understand it clearly. This is an incident ray. When it falls on the normal, here the total ray is getting refracted, and this is angle of incidence and this is angle of refraction, and this takes place when the ray is traveling from one substance into another substance, or from the higher refractive index into lower refractive index. The refraction, this is the best example of refraction. So here there is a bending of light rays. And this sunset is also the example of refraction. So here, because light from the lower part of the sun undergoes greater refraction upon passing through the denser air in the lower part of the Earth atmosphere. Next we will see the refraction of light through the converging lens. Converging lens. Each light ray enters the converging or convex lens. It refracts inward, you know that, and it enters the lens inward again as it leaves. These refraction cause parallel light ray to spread out, traveling directly away from the imaginary focal point. Next one, refraction of light through the diverging lens. So in a diverging lens or a concave lens, each light ray enters in a diverge. There it is converge, here it is diverge. And that means refracted outwards. In the case of convex lens, it refracted inwards. So here it is getting refracted outwards as it enter the lens and outwards again as it leaves. This refraction cause parallel light rays to spread out, travel directly away from the imaginary focal point. I hope you can understand the concept of reflection and refraction clearly. The detailed things we'll see in the next class. Thank you, students.